Good morning. In today's mini lecture, we are going to be addressing the introductions to stoichiometry. Earlier, you had to go through and use my master slide and copy down your stoichiometry road map. So it's really handy to have your complete stoichiometry road map. Now behind me, you're going to see that I created a stoichiometry roadmap, but I left a lot of stuff out. So please use, when you're doing these problems, especially in the beginning, please use your copy of this. All right, what I've decided to do is to create 3 small videos that address one problem at a time. That way, whenever you start working your problems and you get stuck or you need a little bit of help, you don't have to watch an entire video. You can just go back to the one that is going to be concerning the question that you have. So in today's class, what we're going to do is we're going to use all of the knowledge that we've learned so far about balancing equations, about the mole map, about the relationships between particles, mass, volume, and moles. We're going to put them all together and we're going to start looking at how one substance compares to another substance throughout a balanced equation. That is called stoichiometry. So today, the first video, part 1, is going to focus on how to go from a mole to a mole of another substance. So these are going to be what we call mole-to-mole problems. So in the beginning, what I'd like to do is just simply look at the stoichiometry road map. And you can see that we have a particle, a mass, and a volume. That's just like our original mole map, but this time you see that it extends not just to the mole and surrounds it, but it extends from left to right over this way to the same thing mirror imaged on the other side. Well, what this is, and you can probably see that small little dotted line, this is going to be the math that we use for the first substance, whatever they give us in the problem. This is going to be the math that they give us for what we're actually looking for. And if you look, how are the two substances related? The mole-to-mole ratio. And that's what we're going to be looking at over the next 3 videos. So in problem number 1, it says, according to the following equation, how many moles of lithium hydroxide are required to react with 20 moles of carbon dioxide? So in this particular equation, I would like to go through and just write in what I'm given and what I'm looking for. So it says how many moles of lithium hydroxide. So right here, I'm just going to put a little arrow and I'm going to put moles is equal to question mark. So I am looking for the moles of a lithium hydroxide and I'm given 20 moles. So I'm going to write that in, 20 moles of the CO2. So guys, the very first thing is, after you do this, you need to write in your information. Now we know what we're given, we know what we're looking for, we can begin. Before we start, we always want to start with a balanced equation. So I'm going to look at this one and go through and just teeter-totter to balance it. So I have a C here, a C here. I have split oxygens on both sides, so I don't want to mess with that. I do have a lithium, I do have 2 lithiums. So I'm going to put a 2 right there. Now I have 2 lithiums, 2 oxygens, 2 more oxygens is 4. I have 3 oxygens and 1 is 4. I have 2 hydrogens and 2 hydrogens. So this equation is going to balance with a 2 in front of the lithium hydroxide. So it's a 1, 2 to a 1, 2 ratio. So we always start by writing down what we're given. So I am given in this equation 20.0 moles of CO2. Now remember, this is the setup. You always write down the value, you always write down the units, and you always write down what the substance is. I'm going to put this in a factor label box. And then I'm going to come up here to my stoichiometry road map and say, where am I? So I am starting right here with moles. Now, we don't read from right to left, so I'm not going to go that way. I'm going to go that way. So I'm right here at moles, so I'm just going to put a little star right there, and I'm going to moles of my second substance. So I'm just going right here. So since I'm just going from here to here, then it's going to be one factor label box. So always write down what I'm looking for. So I'm going to do looking for the moles of my lithium hydroxide. What do I have to factor out? Again, we always write down the units and the substance of what it is here. Now I have a little bit of a different type of relationship. Instead of using 22.4 liters per mole, or instead of using the molar mass or Avogadro's number, when I am comparing one substance to another substance in a balanced equation, I do a mole to mole ratio. So how many moles in my balanced equation, and this is the coefficients, do I have? And the answer is 2. How many moles do I have here? The answer is 1. So in this problem, yeah, very straightforward. I have 20.0 multiplied by 2, so I'm going to get 40.0 moles of lithium hydroxide. And that's exactly what you do. Now I'm choosing numbers that are, not really small, don't have a lot of decimals in them, just so that we can look at the setup. So everybody kind of got that. Let me go back through and just review what I did. So number one, I read the problem and I wrote in what I was looking for and what I was given. Secondly, I balanced the equation. Third, I went back up to my original stoichiometry road map and said, I'm starting here with moles. I'm going to here because they asked me to find moles. Then I set it up, what I'm given, put it in a factor label box, what I'm looking for, what I'm factoring out, mole to mole ratio. The only time, guys, the only time that you use these coefficient numbers in a balanced equation is when you're doing your mole to mole ratio, which is right here, mole to mole ratio. All right, so what I would like to do is on the second problem, I'd like to go through and set it up, not talk quite as much, but stay a little bit more focused so that you can see how the flow of the problem goes. So here we go. It says, how many moles of ammonia, which is NH3, are produced when 6.0 moles of hydrogen gas react with an excess of hydrogen gas? So I'm going to go through how many moles of ammonia. So I'm just going to put moles, and then I'm going to put equals a question mark, are produced when you start with 6 moles of hydrogen gas, 6.00 moles. So I wrote down what I was given and what I'm looking for. Second, I need to balance this equation. So as I look at this, this is a synthesis reaction, so that tells me that it will balance with a 1, 2, 3, or 4 right here. So I'm going to go ahead and start. I have 2 hydrogens and 3 hydrogens. There's nothing I can multiply by a 2 to get that 3. So I know that the 1 didn't work right off to the bat. Now I have 2 nitrogens and 2 nitrogens. I have 6 hydrogens, and I can put a 3 to get 6 hydrogens. So I balance it with a 3, 1, 2 in here. So third thing is I start setting up my problem. But before I do that, I want to use my stoichiometry road map to make sure I know where I'm starting and where I'm going. So I have 6 moles of the first substance. So I'm starting right here at moles again. And I'm looking for moles. So I'm going here. So again, it's just one setup from mole to a mole. So I'm going to come back in and write down the value 6.00 moles of hydrogen gas, H2. Put that in a factor label box. When I put that in the factor label box, guys, I'm going from here to here. How do I go from here to here? That is my mole to mole ratio. So I'm going to do a mole to mole ratio. I'm not worried about any numbers yet. I just need to set up with what I'm looking for. In this case, NH3. That's my ammonia. What am I factoring out? H2. So now I have set up what my mole-mole ratio is. Guys, to put the numbers in here, all I have to do is look at my balanced equation and say NH3 is 2. Hydrogen is 3. So I have a 3 to 2 ratio. So mathematically, that means I'm going to take and multiply 6 by 2, and then I'm going to divide it by 3 because that is a fraction. So I'm going to come over here and look at what goes on. My moles of hydrogen factor out. 6 times 2 is 12. Divided by 3 is 4 moles of NH3. That would be my final answer. 4 moles of NH3. So guys, what I'm going to do is I'm going to slowly take you through this part 1, which is a mole to mole stoichiometry problem. Then in part 2, we're going to extend it, go mole to mass stoichiometry problem. And then in part 3, we will go from a mass to mass stoichiometry problem. So what it will allow you, or what it's supposed to do, is allow you quick access to the 3 different types of problems that you can be faced with whenever you're doing stoichiometry problems. So I hope that this has helped. Remember that what you'll need to do for your notebook grade is you'll need to come back in and copy all of this down, solve the problems, and then post it into your notebook. All right. Thank you very much. I hope this helped.